All right, Stephen, we've got another story that I think might be interesting to some of the listeners of the rundown out here. MLCommons has released a latest wave of machine learning training and inferencing benchmarks, and NVIDIA's next generation H100 really aced the results. It delivered up to 4.5 times the performance of the leading NVIDIA A100, so they managed to best themselves again. But there are some other gems in these results if you dig into them. A surprisingly strong showing for Biren Technology's BR104 and good enough performance from Intel Sapphire Rapids Xeon to eliminate the market for low performing inferencing hardware. Stephen, you are the man who is all things AI around here. What do the MLPerf results tell us?
Yeah, this is an interesting and developing story. So this was just released, and I'm really pouring through the data now. I've got to say, congratulations, NVIDIA, on your really impressive H100 performance. Now, H100 looked good. The Hopper series really looked good when they announced it. But of course, what matters is where the rubber meets the road. How does it work in the real world? And that's one of the coolest things about MLPerf. So, MLPerf, if you're not aware of it, is actually not a benchmark. It is a wide set of benchmarks that are very, very real world optimized. Our good friend David Cantor and company over there at MLCommons are really focused on trying to suss out not just like who's the biggest and the baddest, but really which product should you use in your situation for your models, for your applications, and how would you know whether it's worthwhile investigating this or that product? And not only that, but the benchmark is really sensitive to how machine learning and AI is actually applied. One of the things that we're seeing here is that there's kind of two aspects of machine learning that are rapidly emerging: training and inferencing. And if you're not familiar with it, training are those big, big jobs where you do a lot of number crunching kind of in the background once to make sure that the model is ready to go and to develop the model. And then inferencing is basically using that technology on a regular basis. So on the training side, well, it's NVIDIA's world. NVIDIA really killed it. They already ruled the training roost. With the Hopper series, they're doing even more. They are delivering easily the best performance across every different model, pretty much. I think there was one maybe that didn't work well, but again, I'm still working through these results. Still, it was a very, very strong showing, and congratulations, NVIDIA, on a very successful delivery of a next generation product. Now, another thing, though, that we see is a very, as you said, a strong showing for Biren Technology's BR104, which is a product from China that was developed independently, natively, as sort of a native competitor to NVIDIA. And guess what? Even though this is pretty much their first generation product, it really works well. It's delivering performance that is not as high as the NVIDIA performance, but in some cases, it actually is competitive with the H100 in terms of per accelerator performance on image classification, for example. And overall, it shows that China has a valid competitor for NVIDIA's forbidden chips, which I guess goes to what we've been talking about here on the rundown with the blockade of China with ML hardware. Now, another thing that's worth looking at is the surprisingly strong performance of Sapphire Rapids, Intel's next generation Xeon platform. What we're seeing here is that Xeon scalable fourth generation processors can run ML workloads fast enough, and I'm talking about inferencing here, fast enough that it really doesn't make much sense to go out and buy a separate inferencing hardware in many cases, because frankly, you can just run it on the CPU. And this to me is another huge takeaway from these results. And it really shows what's happening in this world. If you look at today's CPUs, like the Sapphire Rapids Xeon, like the Apple chips that you find in your Mac and in your phone, And of course, like AMD's next generation CPUs and a lot of the other ARM and RISC-V CPUs, they're incorporating machine learning accelerators for inferencing needs that are really fine, good enough. And once you get good enough on the inferencing side, well, you don't need anything more than that. And so, from a data center perspective, Intel's once dubious claim that you didn't need to buy GPU hardware in order to run ML, well, that claim is starting to sound true. And I think that that claim is going to sound true coming from others as well very soon. And frankly, it's going to really change the face of the AI inferencing market. So, to me, those are the big takeaways so far, but I can't wait to dive in more. And I really appreciate MLCommons for including me once again in the MLPerf briefings.